Imagine your mouth hasn't touched a drop of water in 3 days. Your tongue feels like a dry, swollen block of wood. Every time your heart beats, a sickening, heavy throb echoes behind your eyes. The sun above you isn't just hot, it is a ruthless white laser beating down on a field of dead brown wheat. Your family is waiting back at the settlement. You have maybe 48 hours before your kidneys begin to shut down. You are an ancient human living 5,000 years ago, and the river, the one thing keeping your entire civilization alive, has dropped 15 feet below the steep dirt bank. What do you do? If you try to carry water up that muddy slope, one clay jar at a time, you will burn more calories and sweat out more moisture than you bring back. You will die of exhaustion before you can save your crops. We look back at our ancestors and picture them at the mercy of the elements, praying to the sky for rain, helplessly watching their world dry up or wash away. But that is a profound underestimation of the ancient mind. When faced with the brutal, unrelenting physics of a drought or the terrifying violence of a flash flood, our ancestors didn't just pray, they engineered. They became the world's first masters of fluid dynamics, gravity, and thermodynamics. Let's talk about the enemy, gravity. Water is incredibly heavy. 1 cubic meter of water weighs a metric ton. To move it, to lift it, to force it to go where it doesn't want to go, requires immense mechanical leverage. In ancient Egypt, the Nile was relatively predictable, but as the population exploded, the rich soil right next to the river wasn't enough. They had to farm the higher, drier terraces. To do this, they couldn't just haul buckets. They invented the Shadoof. It looks primitive, a long wooden pole pivoting on a crossbeam, a bucket on one end, a heavy lump of clay on the other. But the Shadoof is a masterpiece of biomechanics. It perfectly counterbalances the massive weight of the water. Suddenly, instead of breaking his back hauling a 40-pound jar up a muddy hill, a single farmer, using only the downward momentum of his own body weight, could effortlessly lift thousands of gallons of water a day. It was the first time in human history we actively hacked the natural flow of water. We told gravity, no, the water goes up today. But what happens when the river isn't gentle? What happens when it actively tries to kill you? Travel east to Mesopotamia, modern-day Iraq. The Sumerians didn't have the gentle Nile. They had the Tigris and the Euphrates. These rivers were fed by distant mountain snowmelt. They were violent, unpredictable, and capricious. Imagine waking up in the pitch black of night to a sound like a low, rumbling freight train. Within minutes, a wall of churning brown mud and water rips through your village, flattening your mud brick home and drowning your livestock. To survive here, humans couldn't just coax the water, they had to cage it. They became the first hardcore civil engineers. By 3000 BCE, they were digging massive, interconnected networks of primary canals, levees, and weirs. This wasn't just men with shovels, this was applied mathematics. If a Sumerian engineer dug a canal with a slope that was too steep, the heavy water would rush through, erode the banks, and collapse the entire system. If the slope was too flat, the water would stagnate, breeding disease and leaving behind a crust of salt that destroyed the soil. They achieved perfect, millimeter-precise gradients over dozens of miles. Maintaining this grid was so vital to survival that it was written into their blood laws. If you neglected your section of the levee and it burst and flooded your neighbor's field, you were sold into slavery to pay for the lost grain. Managing water wasn't just agriculture, it was the absolute foundation of their law and society. Now, imagine an even harsher reality. You live on a high, arid desert plateau in ancient Persia. The sun is so intense that any water on the surface simply boils off into the dry air before it can reach a single root. There are no rivers. The only water is trapped deep underground in the bedrock of the distant mountains. How do you get it? You dig a Qanat. This is arguably the most terrifying and brilliant engineering feat of the ancient world. Specialists, known as muqannis, would go into the foothills and dig a vertical shaft straight down, sometimes hundreds of feet, until they struck the water table in total darkness. Then, using nothing but hand tools, plumb bobs, and an insane level of courage, they dug horizontal tunnels through the solid rock, angling slightly downward for miles toward the city. Because the tunnel was completely underground, the water never saw the desert sun. It didn't evaporate. It arrived at the city ice cold and crystal clear. Imagine being down in those tunnels. Total darkness, the constant threat of a cave-in. Digging blindly through clay and stone to achieve a slope so perfectly subtle that the water flows continuously without ever carving away the floor. From the surface, a Qanat looks like a line of craters marching across the desert, the ventilation shafts used to haul out rock and breathe. Thousands of these ancient arteries are still flowing in Iran today. They turned a deathly wasteland into the legendary lush Persian paradise gardens. But managing water isn't just about avoiding starvation. It's about avoiding the invisible killer, disease. In a dense ancient city, human waste and stagnant water are a ticking time bomb for cholera and dysentery. While other empires were obsessing over how to get water to the crops, the Indus Valley civilization in cities like Mohenjo-Daro around 2500 BCE was obsessed with getting water out of the city. They looked at the filth of urban living and engineered the ancient world's most sophisticated plumbing system. Almost every home had a private bathing area with a waterproof brick floor. But the real genius was under their feet. They built covered, baked brick sewers running right down the middle of the streets. When you used water in your home, it flowed out through terracotta pipes and into a street drain. These drains had perfectly calibrated slopes, inspection holes for clearing blockages, and settling pools to separate solid waste from the water. They literally invented the flush toilet and the urban grid, creating a clean, sanitized environment thousands of years before the streets of London or Paris stopped being open sewers. They understood that water is life, but contaminated water is an agonizing death. Let's shift to a completely different environment. You are in the deep desert of the Middle East, in a slot canyon made of towering red sandstone. You are a Nabataean, and you live in the ancient city of Petra. You only get a few inches of rain a year, but when it rains, it is a catastrophe. The water hits the hard, baked desert crust and doesn't absorb. It funnels into the narrow canyons as a roaring, deadly flash flood, carrying boulders and tearing apart anything in its path. The Nabataeans looked at this deadly weapon of nature and decided to catch it. They carved an astonishing network of dams, hidden channels, and massive underground cisterns directly into the solid rock of the mountains. They turned their entire topography into a giant sponge. When a flash flood roared down the gorge, it slammed into strategically placed dams that bled the violent pressure off, redirecting the calm water into carved aqueducts. These aqueducts fed into massive, pitch-black subterranean vaults coated in hydraulic cement. They took a natural disaster and bottled it, because they hid their water underground, away from the sun and away from their enemies. They controlled the entire desert trade route. No one could conquer them, because no one else knew where to drink. Finally, look at the ancient Americas. The Aztecs built their capital, Tenochtitlan, on an island in the middle of a massive lake. It was a spectacular city, but Lake Texcoco was heavily brackish and salty. If you water crops with salt water, the soil dies and you starve. So, how do you feed hundreds of thousands of people in a salt lake? You build Chinampas, artificial floating islands. They drove massive wooden stakes into the lake bed, wove thick walls of reeds, and filled the boxes with nutrient-rich mud dredged from the bottom. But to protect these delicate gardens from the salt, Aztec engineers built an unbelievable 9-mile-long stone dike straight across the lake. They physically walled off the fresh spring water from the salt water, managing the salinity of an entire ecosystem. If we look around today, we see a massive disconnect. We have PVC pipes, water towers, and digital pressure gauges. We turn a handle and water appears. We flush and it disappears. We have outsourced our survival to a hidden grid, and in doing so, we have forgotten the profound life or death struggle that built our species. An ancient human didn't see themselves as separate from the environment. They understood the terrifying weight of water, the slope of the earth, the way a sudden rainstorm smelled, and the absolute necessity of capturing every single drop. The next time you take a hot shower or pour a glass of ice water from your fridge, remember the ancestors who stood in the baking sun, looked at a river 10 feet below them, and figured out how to make it flow uphill. They didn't just survive the elements, they learned the rules of the planet, and then they rewrote them. Which of these ancient engineering systems do you think required the deepest understanding of nature, and why? Let me know your thoughts down in the comments. If you want to keep exploring the brilliant, forgotten survival strategies of our ancestors, make sure to hit subscribe and turn on notifications. See you in the next one.